Hi everyone, we have a problem here, and in today's video we're gonna find the area of this semicircle shaded region. We know that the area of a semicircle is equal to the area of a full circle, which is pi r squared divided by 2. So in order to find the area, we need the radius of this semicircle. So I can donate the center by O, and we have the radius here and also here. So how we can find the radius? The only information we are given is this length, which is 6, and also this length, which is 4. So we can use different theorem to find the value of AC and BC, and finally the value of R. The first theorem that we have is Tangent-Secant Theorem, which when we have a circle and a point outside of the circle, if we have two tangent lines to this circle, and I donate these by A and B, we know that the tangent segments PA is equal to PB. So we have here point B, and from this point we have two tangent lines, BD and BC, and these two tangent lines according to this theorem are equal. So we can write BD is equal to BC is equal to 6. So we have 6 here. Another thing we can use is the Pythagorean theorem, because we know the hypotenuse length and also this leg. By Pythagorean theorem we can calculate another leg. So we have here a right triangle A, B and C. The length of the hypotenuse is 10, the length of BC is 6, and the AC is the length we are looking for. So we can write 10 squared is equal to 6 squared plus segment AC squared. So we simplified. 10 squared is equal to 100, 6 squared is equal to 36 plus AC squared. If we subtract 36 from both sides, we will get 64 is equal to AC squared, and we know that 64 is the perfect square, so we can write AC is equal to 8. So we have here AC, which is equal to 8. If we subtract these two R from 8, we will find this length, which is 8 minus 2R. Another theorem can use to find the value of R is the Tangent-Secant Theorem. And when we have a circle, and from a point out of a circle we have a tangent line and also a secant, and if I name these points as A, B and C, the square of the tangent segment is equal to the product of PB times PC. For this problem we can consider point A as the point that we have a tangent line and a chord. So we can write 4 squared is equal to this segment times this segment. So we can write PA, which is equal to 4 squared. PB is 8 minus 2R times 8, the whole length of AC. If we simplify it, we will have 4 squared is equal to 16. 8 times 8 is 64 minus 2 times 8 is 16R. If we add 16R to both sides, we will get 16R plus 16 is equal to 64. And if we subtract 16 from both sides, we'll get 16R is equal to 48. And now we can divide both sides by 16, and we will get R is equal to 3. So the value of the radius is 3. So we can now calculate the area, which is pi r squared divided by 2, we have pi r, which we already found is 3 to the power of 2 divided by 2, and we will have 9 pi divided by 2, and finally we have 4.5 times pi. That's the final answer to the problem.